Air conditioning systems create a comfortable temperature and humidity inside the passenger compartment, so the driver and passengers feel more relaxed and cool. And the driver is then able to concentrate on driving, which leads to increased road safety. Air conditioning operation relies on taking heat out of the passenger compartment by absorbing the heat into a refrigerant that transports the heat away from the passenger compartment so that it can be released to the outside air. The main components of an air-conditioned system are the compressor, the condenser, the expansion valve, and the evaporator. And the refrigerant used to absorb the heat in most air conditioning systems is known as R134a. But since January 2017, new car air conditioning systems must use R1234yf for environmental reasons. We can now look at air conditioning operation in greater detail, starting with the compressor that creates the flow of refrigerant through the air conditioning system. The compressor is usually driven by the engine using a drive belt with a magnetic clutch being used to engage and disengage the drive to the compressor. For some systems, a DL pulley is used that continuously drives a variable displacement type compressor. And for electric and hybrid vehicles, the compressors are driven by electric motors. To provide lubrication, a specific amount of special compressor oil is added to the refrigerant. The compressor creates a high pressure at the discharge port and a low pressure at the suction port. The compressor sucks in the gaseous refrigerant from the evaporator, where this superheated refrigerant has absorbed heat from the passenger compartment. The gas is then compressed, which adds additional heat, and the high-temperature, high-pressure gas is then forced from the compressor discharge port to the condenser.
The Snowcool subcooled type
Condenser operates using the same principles as a domestic radiator. Because the condenser transfers heat to the air, the condenser is divided into 4 main sections. A gaseous section to remove the heat from the hot gas. A condensing section, a gas-liquid separator known as the modulator, and a subcooling section with the high-pressure refrigerant flowing through these 4 sections in that order. The gaseous, condensing, and subcooling sections consist of tubes and fins, and as the refrigerant passes through the gaseous section, the heat contained in the high-temperature refrigerant gas transfers through the fins to the outside air. This loss of heat reduces the gas temperature, which allows the gas to condense within the condensing section, where it naturally changes state to a liquid. The liquid refrigerant then passes to the gas-liquid separator section, where any remaining gas is separated from providing further opportunity for the gas to release heat and change to a liquid. The liquid refrigerant then receives additional cooling in the subcooling section, where the heat energy contained in the liquid refrigerant is again released through the condenser fins to the air. This further reduces the temperature and improves the overall cooling performance. Next, the cooled liquid refrigerant flows to the expansion valve, where the high pressure of refrigerant forces it through a small orifice or hole, and this has the effect of injecting the refrigerant from the orifice as a mist that is then able to expand. The expansion allows the pressure to reduce, which also reduces the temperature, and this causes the refrigerant to again change state from a warm, high-pressure liquid into a cooler, low-pressure mist that is able to more easily absorb heat when it passes through the evaporator. The expansion valve also adjusts the quantity or flow of refrigerant passing to the evaporator. Too little or too much refrigerant results in too little or too much heat being removed from the passenger compartment. The low-pressure mist refrigerant now flows into the last major component of the air conditioning system, the evaporator, which is located within the air conditioning unit. The evaporator consists of a tank, tubing, and fins that are exposed to the air in the passenger compartment. Therefore, heat from the air is able to transfer to the fins and it is then absorbed into the refrigerant mist. And at the exact moment that the refrigerant absorbs this heat, it vaporizes and changes back to a gas. This superheated gaseous refrigerant then flows from the evaporator and back to the compressor, where the whole process starts again. We call this whole process the refrigerant cycle. One final and important component
Fitted to Snowcool air conditioning systems.
is the pressure sensor that is used as a simple safety device. The sensor detects the refrigerant pressure on the high-pressure side between the condenser and the expansion valve. So if the pressure is incorrect, which could cause damage to the system components, the compressor can be switched off.